Hello students. Uh, Today I am going to discuss another problem on fluid mechanics, which is very important. The question is, a liquid of density rho is filled up behind a square wall of side length L. Find the net force on the wall and the point of application of the force. So the given configuration of the liquid and the wall is like this. Uh, for this, if you see this water is filled up to height of length L, okay, up to height of L, okay. So at each and every point of this wall, every height of this wall, along the pressure is different. Pressure will be different because as we all know that pressure is proportional to height. That means pressure varies with height, okay, proportionally, right? Pressure varies with height. So now for this kind of problem, since pressure is varying for each and every section of this wall, so we will take one small element of this wall in the shape of this, okay. So at a distance x from the top of the wall with a thickness of dx, okay, this small strip. Now on this small strip, the force due to this pressure will be p will be equal to p atmosphere plus rho g x. This element since this element is, let me name it as b, that is p at b, uh, is at a height x from the top of the wall, and this free surface of the liquid is exposed to atmosphere, so this will be your p atmosphere. So net for pressure on this particular element will be equal to p atmosphere plus rho g x. Now the net force on this particular small element, okay, df, it will be equal to p into dA. This is the small force on this small element. So dA will be equal to your, you see, this is your length L, and this is your thickness, that is dx. So dA will be equal to L dx, okay. So net force, if we write df is force on the small elemental area, is your p atmosphere plus rho gx into dA, okay. So p atmosphere plus rho gx into dA is your L dx. So this is your df. Now we need to calculate the net force. So for net force, what we will do, we will integrate this for net force, okay. F net is equal to p atmosphere plus rho gx into L dx, okay. We need to integrate from 0 to L, obviously, because the height varies from 0 to L, okay. Now let me integrate this for the net force, okay. Now if we will integrate this, what we will get is equal to uh, p atmosphere is your constant, then L is your constant, integration dx remains, so 0 to L you need to integrate this, plus rho g L is constant, and x dx you need to integrate this from 0 to L. So what you will get is that p atmosphere L, again this will be your L plus rho g L, this will be your L square by 2, right, after integrating. So we will get p atmosphere L square by L square plus rho g L cube by 2, is it? So this is your F net force on the wall. This is the expression for net force on the wall. Now next we will go for the torque equation, okay. Now for the torque equation, what we will do, we will take the torque of this small force, okay, this small force dF will be in this direction, okay, dF is equal to pda about this point O, topmost point O. For the torque, we will find out the torque about this topmost point O, which is at a distance x. So let me find out that d tau is equal to how much? Is x cross df. Is it x cross df? Now both d is having the 90 degrees, so it will be x df. So if we do this, if we put the values, what we will get is your x into df. What was the df? So df was this much. Df, put it here, p atmosphere plus rho gx into dA is your ldx. Is it ldx? So what remains is p atmosphere l x dx plus rho gl x square dx. Is it? Now we need to integrate this for net torque. For net torque, let me integrate this. Okay, now we will integrate this for the net torque. Okay, so tau net will be your integration of d tau is equal to integration from 0 to L, obviously, p atmosphere lx dx plus integration from 0 to L rho gl x square dx. Okay, so if we integrate this, p atmosphere is constant, L constant, then integration x dx from 0 to L plus rho gl is your constant, integration x square dx. So what we will get, p atmosphere into L, so this will give you L square by 2 plus rho gl, this is your L cube by 3, is it? So net torque will be equal to P atmosphere L cube by 2 plus rho g L to the power 4 by 3. Okay, so let me put this equation number 2. Okay, this is a net torque equation and this is your net force. Okay, now for the point of application of force, what we will do, we have net force as this. If we suppose that as this F net x at a point which is at a height h from the top of the wall, okay, then what you can write for the torque, is tau net equal to F net into h. Okay, now what is the F net? Our F net was P atmosphere L square plus half rho g L cube. Is it? We have already calculated this here. This one, P atmosphere L square plus half rho g L cube. So now into h will give you the into h is our net torque. Now we need to equate these two equations because this tau net and this tau net has to be equal. Okay, this tau net and this tau net both has to be equal. Let me put this equation as equation number 3. Okay, equation number 3. Equating equation number 3, 2 and 3. Equating equation number 2 and 3, what we have is P atmosphere L square plus rho g L cube by 2 into h. This should be equal to P atmosphere L cube by 2 plus rho g L to the power 4 by 3. So from this we'll get H equal to P atmosphere L cube by 2 plus rho g L to the power 4 by 3 divided by P atmosphere L square plus rho g L cube by 2. Okay. So this is the expression for point of application of force which is at a height h from the top of the wall. Okay. Now if if P atmosphere is negligible, okay, if it tends to 0, then this will tend to 0, this will tends to 0, then H will be equal to your rho g L to the power 4 by 3 divided by rho g L cube by 2. So this will give you twice L by 3. Okay. So H equal to twice L by 3 from the top of the wall. Okay. From the top of the wall. And it will be equal to L by 3 because it is L minus, then we need to take it as L minus 2 L by 3, then it will be L by 3 to from the bottom of the wall. Okay. So this is all about the net force on the wall due to the liquid behind it, and then the torque acting on the wall, and the point of application of force from the top of the wall and from the bottom of the wall. So this is all about this. If you require any explanation, then feel free to ask me. uh, Thank you. I hope you all have understood this one.